understand why we chose Node to do our project. You'll have a real-world security issues we found with the mean stack, and I'll go through that later. And then John will present on processes and some tooling to do even your own testing, as well as what a penetration tester would do if you were to hire them to do an assessment on your website or product. So the project was, we had to do a proof of concept. It was a Swinburne project, and it was proof of concept on a file transfer sharing web project that needed crypto end-to-end, like zero trust server type of model. We had to see if it was going to be feasible, whether JavaScript crypto was good enough currently to achieve a high level of security, and whether we can actually get a usable, user-friendly product out of it in the end. And so before I can go on, this talk will potentially be broken up into two parts. So this part's very focused on kind of the avoidable attacks, so implementation issues that a developer has done not on purpose. There's obviously a lot of other kind of threats and attacks that a hacker can get into via, like the JavaScript environment not being capable, or getting malware on your browser or on your computer, or exploiting a vulnerability in a browser. So you can't really help these issues too much as a developer. So I won't be going through any of these tonight, but just to give you an overview of what you do have to consider when you are developing a software product. But yeah, so we'll be focusing on the bottom ones here. So just quickly, it's a pretty typical kind of client-server model with the web application. I'll go through a small demo soon, what we've actually achieved. And yeah, we're just using S3, their own like Heroku servers, and just regular kind of client-side application stuff. So Node.js is basically a platform that allows JavaScript to run on the server and interact with the OS. So if you're familiar with any other web server language, then it's basically the same thing, except it's using Java. So it's using Chrome's V8 engine. So it's quite fast, single-threaded, which we'll get back to soon, and cross-platform and single language. So there's quite a few advantages. It's quite a new platform as well. So yeah, the main disadvantage, as a lot of people seem to say, is the callbacks. You get this callback hell type of environment, and that is because you have the clients that send requests to this event loop, and that's the single-threaded part of it, and then that gets shot off into some non-blocking workers that then handle the request, and then when that request is done, it sends a callback to your application, and then you process it. So yeah, it's not that small anymore. It's come out only a few years ago, or like 5 or so. I can't remember exactly when it came out. But there's a lot of big guys starting to use Node now, even if not for their like smaller part of their project, but for their whole development lifecycle. So it's not in the shadows anymore. So, but why did we choose it? As I said before, performance, scalability. There's a lot of different things to warrant using Node.js in your stack. So the problem security professionals face is they don't like new things, because everything new hasn't been tested. Well, not every security professional likes new things. So anyone can publish a module. So you have all this whole kind of network of modules out there that are really fantastic and will make the platform really easy to use, and it's like kind of simple and easy to extend with these modules. But then the downside is that anyone with a GitHub account and the proper process can then just export one of these modules that they've created, and the public can start using it in their production environment. And as we'll see today, we've got a few different things about Node.js and what they've done, and also MongoDB and how you can secure those. So yeah, we used basically a mean stack without the A. So we chose not to use Angular, mainly because it's a bit too heavy. But the rest we've used. So we used MongoDB and Express, which is the web application framework, allows you to do REST, APIs quite easily, and handles your web server stuff as well. And then yeah, Node.js obviously brings all these things together. Now MongoDB is, who's heard of MongoDB? Most people, great. So it's a NoSQL database, and we'll be going through a few different issues compared to MySQL and why the security issue is different, and how you can get into some trouble. So 3 months later, we got this proof of concept done. Turned out to be a success, and it was time to harden the project. So we basically focus on the second part of the presentation, which would be the design of the crypto and making sure it was user friendly and all that type of stuff. And then we finally had some time to concentrate on the security and implementation details. Now, if I can do this. Oh, there we go. This hasn't frozen. Just give me a second. Okay. So it's a pretty simple user interface at the moment. Register, login, typical stuff. I've already got an account, so I'll just quickly really secure. I might sit down a bit easier. Alright, so you can see that we've got ability to add folders. Inside each folder, you can add upload files. Now, anything you store on the server, you can't hear. Hello. Okay. I think it's a restaurant or something. Alright, is that better?
Yeah.
Alright. Yeah, so we've got folders on the left, and obviously you can upload and download files. Now, anything on the server has been designed so that even if the server is compromised, they can't do anything, because all the encryption is done in the client side with the JavaScript. So there's not much to it. There's the ability to share, so you can add a person via email, and upload and download files, and a few messaging things as well. So it's a very basic proof of concept that you can securely upload and onto a server and share a file securely without trusting the server at all. So that's basically it. Okay, let's Okay, so basically, during your software development lifecycle, you should be concentrating on security a lot. I don't want to iterate this too much, but it's something that not all organizations do, is they kind of leave security to the last minute. You know, there's not enough budget or whatever it is, and then, you know, obviously there becomes vulnerabilities and problems in the end product. Yeah, so you should be implementing security in every phase of your development lifecycle. It doesn't have to be a tedious task. Once you've got it set up, you can do some automated things that make your life much easier using some pretty cool tools that you can integrate directly into your integration, testing, and a few other things. I've already discussed this, so you can have a look at that a bit later. So Hardening Express, which is the web framework, there's a library called Helmet, and it basically does everything for you. It's quite cool. So you just got a few lines of code that you can grab. Their GitHub page gives you instructions pretty easily on how to do that, and that takes care of a lot of header issues that makes, if you want to put your website only serving over SSL, it gives you the ability to make sure you've got the HTTP strict transport security headers in there. So it gives you a lot of options to easily configure. So the first thing we ran into, and this is kind of where the talk came about, is that we ran into several issues during development, and I just wanted to mention just those issues. There's obviously a lot of different attack vectors, a lot of different issues that can happen, or implementation problems, but yeah, I'm just going through a few easy ones that are good to have in your toolkit and that we had issues with. So hardening the web server is the first thing. And you can start off by doing some good configuration with Helmet. Okay, so server-side JavaScript injection. I won't go into this too much because I think John's going to cover that a fair bit later. But who can tell me what the eval function does if anyone's done anything heavily with JavaScript before? I personally have never used it because I know what it entails, but yeah, same with the set timeout. Basically, it takes a string and it interprets it as JavaScript if you're putting JavaScript in there, or as a string. So basically, interprets anything you do. So, for example, this is a pretty mundane example, but if you have some user-provided input, say first name and last name, and you say you want to run this bit of eval code, that's going to make, in the best case scenario, it's going to say first name, last name, and put it together and make the full name, and then you'll have a variable after that called full name. If someone injects some a comma in there, and they can then rewrite some JavaScript and run basically arbitrary JavaScript on the server. So making sure you've sanitized the input or just not using eval in any case, unless you really have to. But yeah, John will go over that a bit later on in more detail. So I just wanted to point out that you don't have to use MongoDB with Node.js. Even though most people do use MongoDB, you can still have drivers for MySQL. Now, can anyone tell me what the difference is and why, or which one's better? Can everyone see that, or is it too small? So the second one's better, third? Why? Escaping input? Why is that a good thing?
They're both pretty bad.
They're very mundane results, mundane examples, but. So I think we all agree the second one is better. The reason for that is we have the escape of the user input. So this allows special characters to be taken out before it gets interpreted by the SQL compiler when it gets down into the database. So I'm kind of mentioning these very briefly. If you don't understand what an SQL injection is, you're probably going to be a bit confused. But if you read the top 10 OWASP guide and you look up some OWASP references, it'll explain exactly what it is and you'll get more detail. And I think in future presentations, if there's enough people interested, we will go through this in more detail. But the main point of this presentation is just to keep you aware that these type of things exist, not to show you exactly how they're done and what they are. So MongoDB actually says that they're immune to SQL injection, or at least the regular kind, because they create these BSON objects, which is like a JSON equivalent, but a binary representation. So instead of parsing a string, which is the problem with SQL injection, now you're actually creating this object, which makes it like immune to these type of parsing errors when you're not parsing input correctly. So what else I wrote here? Nope. But there are new forms of injection attacks, and I'll give you an example of that. Okay, so this is a regular SQL query, and then this is a MongoDB query. If you can see that, I'm not sure if it's too small, but it basically creates this object. It almost looks like JSON, instead of just accepting a regular string. And this, even if the user ID contains some random values, it doesn't interpret it badly because it's actually in an object rather than in a string. Does anyone have any questions about that? I know it's very quick and a bit vague, but no questions? Who doesn't know what an SQL injection is? Don't be shy. Serge doesn't know. Yep, okay, good. So MongoDB doesn't, it's got kind of a different concept. So it is kind of a prepared statement in the fact that you're inputting it into this user object, or this kind of object here, but it doesn't need prepared statements because you're actually forming an object itself. So you're kind of amalgamating the prepared statement into one, so it's kind of a little bit different. Does that make sense? Dude, Yeah, prepared statement is normally you put like values in your string and then in the actual query. Yep.
What was the injection you mentioned from Mongo?
I'll get to that in a second. Okay. Alright, so this is just an example of Mongoose, which is a kind of a layer on top of MongoDB. It just gives you a bit more functionality. It's very similar. As you can see, we're still creating this object, and then we're saying find some user in the database with user ID coming from the user. And then we execute the function and we get the result coming back in the user variables there, and any errors that occur. This is a very standard syntax for Node.js because you've got this callback function. So yeah, this is not procedural code. This is in the callback. So yeah. And this is an example of a schema. So Mongoose also allows you to do schemas instead of raw objects. So now we have a similar thing to like Hibernate or like regular object. So this is now going to be put into the database as a user. So your first name, last name, email, and so on. And allows you to do really cool things like types and required. And
So this is equivalent to constraints. SQL.
Yes, yeah, constraints in SQL or Java or whatever you want. JSP. And the reason I mention this is you'll see later on we're going to do an attack on this isAdmin field, and where we set the admin to true when it's not meant to be true. So this is the new generation of attacks that have come about. It's not as big of an issue now because MongoDB have updated their software after a few papers have come out in 2012. But we have certain functions that we can push into the MongoDB database during the query that allow you to run JavaScript on the server. So in the where clause, you can say where and have some JavaScript there that's doing something in a query. And if you don't properly sanitize the JavaScript that goes into there, then you'll get anyone can run code on the server basically. And this is a bad idea because that gives you access to the DB object in MongoDB that can tell you things like how many tables there are, what the actual values are, so that an attacker can actually extract a lot of information if they're putting bad things into their inputs. Now, I mentioned that they've fixed this, but we'll go through an example first. So this is, we're going to find where first name, so the user first name is provided by the user, and we're going to say this.firstname is equal to first name of the user. We're going to find, say Bob, for example, in the database. And obviously this is JavaScript here, so this actually gets run on the server in the first example. The second example is of an actual attack scenario of where this could go wrong. So you just have to, can everyone see this little string here? It says A semicolon sleep for 1,000. So an attacker, to see if they can actually exploit a vulnerability, they'll test out the network and say, hey, if I put this sleep in there, if the request takes 10 seconds to come back, I know that I can inject JavaScript in there and then start exfiltrating some data while doing other malicious things. So in general, it's a bad idea to allow this, and recently they've actually updated the database so you have the option to turn that off, so you don't allow JavaScript to run in the server. I think that's off by default. Do you know if that's correct? Sorry. JavaScript running on the server. If it's not off by default, you should definitely turn it off. Because most of the time, I mean, in my experience, you never really have to use these functions. But if you do, then obviously you need to be careful. Any questions on that?
Can you, instead of running JavaScript, go back, update a schema object?
The question was, can you update a schema object on the fly? You can run anything in here on the server, so you have access to the DB object, so you can actually change or modify schema values.
Running it, but plus JSON.
Depends on what, I'm not sure. I have to think about. So you're saying you want to pass in a JSON object and change what was going to happen, or you want to add a JSON object into the database?
Not change the actual schema.
You might be able to, because you have access to the whole DB object, which gives you schema access, it gives you everything. So yeah, you probably could, because you can read the table names and modify it. Yeah, I think you could. Yeah. But I haven't looked into that. Anyway, so this is where I mentioned they fixed it after 2.4, after Brian Sutherland's article, and they've actually tightened the security a little bit. They've made you, they can disable JavaScript and also restrict the available commands that you can run on the server. So if you have to enable JavaScript, you no longer have access to that DB object, which means you can then modify the schema or do whatever you want, or look at table names. So they're limited to a subset of functions that you can now limited to on the server. However, you are allowed to add like JavaScript functions onto the server as well. So if you want to add a custom function onto the server, they could then call that function. So in general, it's a bad idea to do this, and they even give you a warning that it's not recommended on the website. So yeah, just put that in there. That's probably a pretty bad idea. Any questions so far? I'm not going to get into cross-site scripting but who knows what cross-site scripting is and why it's bad?
You want me to explain it? Oh, right. I'll create execution of JavaScript.
So cross-site scripting is one of the biggest, still one of the biggest issues in web security. People still don't understand how to mitigate this. Even in ASP.NET applications, hardened, they've been around for years, they still get susceptible to cross-site scripting. That's one of the things security professionals find a lot of, because it's hard to get that right. The reason is there is only so much you can do you have to be really familiar with how cross-site scripting works and making sure that you're, so who doesn't know what cross-site scripting is? Serge again. Alright, so cross-site scripting, as Sam mentioned, I'll give you an example. If someone, I should have given an example on here, but if someone, there's different types of cross-site scripting. So there's stored and reflected, and there's another type that's a little bit more advanced. So stored is when someone, say you got a message form and you upload, a script tag saying script document.cookie or something onto a message form, and then someone later on views that message board, and that JavaScript that you wrote in that message form actually gets executed. So basically you're scripting on someone else's website, so cross-site scripting. The way you mitigate that is by encoding, so you want to make sure that script tag gets encoded and the actual elements are not allowed, or they're encoded into, is it HTML encoding? Yeah. So anyway, there's a few libraries that are kind of a little bit new, and this is a bit of a problem in Node.js. I wasn't able to find any really strong, decent encoding and sanitization libraries. There is a few kind of popping up, but they miss a few. They don't allow you to do context-specific encoding, which means, and this is getting a bit deeper down, if you do HTML encoding, but then you put this input into a JavaScript element or into an HTML attribute, then you're still at risk of cross-site scripting. I just wanted to put this here because there's a bit of a problem here and we need to fix that soon. Now, mass assignment, this one was actually a really cool one, and I came across this because I was looking at some tutorials on this exact topic and realized straight away that I had done this in my own code, because I knew exactly what it was, and it's very easy to do this in Node.js, which is why I'm bringing it up. It's not a very known vulnerability, but it's an important one for JavaScript especially, because it's so easy to do this, and I'll go through it. Now, So this is basically the same problem Ruby on Rails had in 2012. So Node's kind of catching up slowly, but still lagging behind a little bit. I think GitHub was involved in an incident where they had this exact vulnerability and allowed them to, an attacker to get some information. I can't remember the details, but it was a pretty big issue at the time. Alright, so an example. We're just going to create a user. Now this is just a simple user, say if you're going to register in the page or whatever you're doing. Now, we've got a bit of code here in the register function that says, alright, I want to create this new user, and I want to grab the body of the request. So this is a post request to API/register, and we're passing in the first name, last name, and the email. So it's pretty standard. What we're doing here is we're creating a new user, which we're then going to save into the database. And then if they are an admin, we're going to do some bad things, because they should never be an admin in this case. So, can anyone tell me what's wrong with this code and why it's bad? You think, because this is a very, very usual case that you just do this, because it's very easy for a programmer. Instead of saying, you know, new user, and then down here say new user dot first name equals request.body.firstname, and then you say new user equals. So you have to continue on doing this, and it's a very tedious process if you have a lot of parameters in your user schema.
So you just add the parameters into the request.
Yeah, so right, so let's have a look at the schema again. We can see first name, last name, email. Right, so that's good. So when we put this request.body into the user constructor, it goes into the user schema, creates an object with first name, last name, email. Perfect. That's exactly what we wanted. Less coding, just a one-liner. What happens if an attacker, when you're registering for the application, sticks on at the end, is admin equals true? Then when we pass request.body into the constructor, it's going to assign is admin equals true, which is exactly what we said. So yeah, pretty big deal. You have to know the schema, obviously. But it's pretty easy to guess what the parameter name might be. Normally, his admin's a pretty solid bet, and then obviously admin rights.
Can I point out something else wrong?
What do I do?
If it's admin, it just deletes the entire server.
Yeah.
Protect
yourself.
It won't actually. Most non-BSD systems that won't execute.
Yeah, you might. And or sudo, yeah.
That's all you do when you're admin anyway.
Yeah, it's making it a bit fun. It's obviously not production code.
Yeah.
So yeah, fixes for mass assignment. This is a pretty big issue. You got an NPN module called Mongoose mass assignment, which helps you out a little bit, and you also can do a whitelisting. So you can use underscores.pick, and then in your user schema you can have email, first name, and last name. And these are the only fields that will be populated if you are putting that value into the constructor. Does everyone understand that? Is that pretty clear, or? Which one? So the user schema that's status. User equals. Yeah, so this was in the schema. So in Mongoose, this is a way of adding to your schema, like some values. Yeah, and then this would be in your code, where it was before. So you replace this with that bit of code, with the .pick. Yeah, so you use them. And then grabbing the, basically just an array of accepted values. Alright, I'm going to pass it over to John now.
I was engaged by Mr. Hard down the back there to do a little bit of a pen test on the ArcGX environment, and it was a little bit different to what I'd done before. Normally I looked at a specific company, or a specific device, like a Wi-Fi router, and attacked that. So this was a little bit different. It's application only. It was only a POC, so I was so it was in the client's best interest to have the concepts audited for the security rather than finding every single little issue around. So that's what I was concentrating on. The other interesting thing was, as it was mentioned, is it's hosted on Heroku, how do you say it? Heroku. And that presented a little bit more difficulties from sort of a legal standpoint. Who can guess why having an application hosted on something like Heroku would be problematic for a pen tester? Yes, that's right. Yeah. So you've got a whole bunch of legal problems, and you basically can't do a whole lot of things that you'd otherwise like to do, because it's not technically the customer's environment; it's now some third party's environment.
Well, you can do permission. AWS does have a standard format for getting permission for that sort of stuff.
Yes. Yeah. So presumably Heroku honor that, but who wants to know? And it's not really the point in this case. So I was concentrating on the parts that were important to the customer. And for the rest of the talk, I'm going to be looking at the tools that not so much that I use, but that would be used in attacking a website. Things that I think might be more useful to more of a developer environment. So these are not necessarily what someone versed in the field would do, but these are easy things and easy tools to use that you could and should be using in your development in order to secure your programs. So on the previous slide I mentioned there was 4 steps: the reconnaissance, scanning, exploitation, and maintaining access. And those are the 4 basic steps that a pen tester will use when they're doing their work. So I start off with a reconnaissance. Again, this is not something that I did for this particular engagement, because I knew the people. I don't have to be sending them maliciously loaded PDFs because they gave me access to the source code. So it's a sort of a different take on things. But when you're looking at where you're exposed, one of the things a pen tester will do is use Google and other search engines and find bits of your website or bits of your corporate systems that are exposed to the internet that you may not realize. And there have been cases where people have been able to find the tax filings of the company that haven't been released yet. They've not been made public, simply by going to Google and guessing that the previous year's was 2012, this year's was 2013. I wonder what the folder name will be for next year, and getting the numbers and doing something evil with it. So Google and Google Docs, there's a website called Johnny No Hack, I think it is, who's got a website full of interesting what are called Google Docs, which are specific search queries that find you interesting things online. An example might be the administrative config file that you use to set up MediaWiki, and that can contain the administrator password and the password hash or other things. So there's a whole bunch of interesting things to find without even trying. Harvesting emails is very useful. There's a utility on Backtrack Kali called the Harvester, where you punch in a company name and it uses various search engines to find people who have used their company email addresses on the web somewhere. And that's a useful list to have if you were going to be doing a malicious PDF or a drive-by attack. Other interesting useful information if you're doing more of a web-oriented pen test is Netcraft and sort of other tools like Whois and Dig. There's a lot of information that you get for free there. So here's an example of Netcraft for the Heroku app. It gives you not only just the IP address, but where the hoster is physically. You get things like the hosting history. You get the fact that it's hosted on E2C, that it's using Heroku, SSL, JavaScript enabled. You also get the client-side technologies that are being used, like jQuery and Score, Bootstrap, and you get the headers that are used, and a lot of other things that can be useful going forward. And this is all without touching the website, which is a really good thing. If you can avoid touching the actual customer site until you actually have to, you should. So make use of the online tools that are available for free to make that happen. Alright, so the next phase is the scanning step. So you've got two basic or broad levels of scanning. You've got network level scanning, where you find IP addresses that are owned by a company and you look at what's available on there. You've also got the application, if it's more of a web-oriented pen test, then you've got the application vulnerability scanners. And for both of these, there are ones that are sort of free. They've already been done for you. We'll go into them a little bit. So yeah, so the few that I think that people should be aware of is NMAP. Presumably everyone's heard of NMAP and comfortable using it. There's quite a lot of options. There's a really good book out there called, I think it's the NMAP Cookbook Guide. I highly recommend that. NMAP will find open ports, and it will even go down to what operating systems are running, or versions of the kernel of that operating system based on various metrics. It'll also do banner scraping, so it'll determine what version of the service that's running on a particular port. And you should look into not only just doing TCP, but also UDP, also IPv6. And if you don't want to touch the site, because perhaps you're doing it from your own network, or maybe you shouldn't be doing it at all, there's an online version that I recommend using. There's also an open source tool called OpenVAS, vulnerable application something, and it will do a reasonably good job of looking at what is available on that IP address and determining how one would go about attacking it. Another one that I use at home for my home network is Nessus. It's free for non-commercial use, and I just set up a VM with it running, and every weekend it scans my entire subnet and emails me a report along with remediation recommendations. So it tells me where I'm vulnerable, and I will have a look at the screenshot of that. There's also Shodan HQ. Anyone heard of Shodan? No? Yes? Yes? It's a bit like Google, but instead of scraping web pages, it scrapes open ports on the internet, and it does banner detection as well. So if you happen to find a 0-day in, say, MongoDB, and you wanted to know all the IP addresses that were running MongoDB, that's where you go and win. It's great. And finally, SSL Labs. So if you want a really quick, easy way of working out whether your SSL setup is correct, whether you're using cyber suites and so on, SSL Labs will give you a really nice, easy to look at C-level executive sort of grade. It's quite easy to put that in front of a boss and say, we need to do something good. So here's NMAP. This is running against a host I own, so it's legal. I've hidden the details because I don't trust any of you. There's running 3. This is just a TCP. This is a TCP level scan. It's running 3 services: OpenSSH and my mail. It's also determined that it's Linux, and it's determined the kernel version. I checked, and it's not quite right. It's a little bit newer than that. But from that, you can more or less determine that it's running dead version 6. That is relatively up to date. So that's NMAP. This is Nessus. This is a screenshot from Nessus. This is part of the email reports that I get every weekend. So I've got 3 ones for host enumeration to make sure that there's no nasties running around on my network. The second one is vulnerability detection. And this is a screenshot from that. So it's determined that it can connect to various SNMP hosts, so it's a UDP service. And apparently the community name is public. It turns out I tracked that down to a temperature humidity monitor in my rack, and it's this tiny little device, and I can't upgrade it, and it's pissing me off because it always alerts me, but there's not much I can do. And it's also self-updating, so it keeps itself regularly up to date with the latest vulnerabilities. This one was taken from this week's scan, and it already knows about the change cypherspec vulnerability in OpenSSL, which I'm sure everyone's aware of, because it's really bad. Not quite as bad as Heartbleed, but bad. This is Shodan HQ. This is a search I did for MongoDB. and it came back with just under 90,000 hits, which is great if you had 0 data there. So yes, so have a look at that. Don't do anything naughty. That would be bad. This is SSL Labs for a website in BR, which I believe is Brazil. They got an F because they support SSL v2, which is obsolete and insecure, so they get an F. That's bad. While I was doing the pen test for the Heroku, for RPX on Heroku, it started off with a B, and interestingly, they upgraded their cyber specs while I was doing the test, so they got an A after that, so kudos to them. Okay, moving on to the application level. So this is more where the OWASP movement is, I think. The OWASP 10, OPTAP 10 applies more to the application level. So you start off with the intercepting proxies. I'm sure everyone's heard of Burp Suite. It's an intercepting proxy. You get to send a request in on your browser, pause it in the intercepting proxy, perhaps modify it to do something that wasn't expected, and see what comes back from the server. So Burp Suite's good. Unfortunately, it's commercial, but they do have a free version, but it's limited. So hamstrung in various ways. The one I use is the OWASP app, yay for OWASP, and it's pretty good. It's scriptable. You can do a lot of things, and it's even got a noob cannon feature where you just type in the hostname, and it does a website crawl, and it tries to inject on all the parameters that it can find, does SQL map, line SQL injection, and a bunch of other things. So that's a really good one to start with if you don't know what you're doing, and it will find the low-lying fruit for you for free. Unfortunately, it's very noisy, so if you're not doing it on something you own, then we'll probably, if they're looking at the logs, hopefully detect you, and yeah, that would be bad if you weren't supposed to be doing that. If you come across any specific technologies like WordPress or Joomla or even SQL, there are a lot of dedicated applications specifically for those technologies. I've used WP Scan before, and it's really good at determining what themes and what extensions have been loaded. It'll even go as far as to tell you what version of that extension, and it'll also look up on on the open source exploit DBs whether or not that particular feature is vulnerable, and it suggests how you would go about exploiting it. It'll do user enumeration, and it will brute force the admin account if you really wanted to as well. SQL Map's good as well. It requires a little bit of hand-holding, but there's a wizard mode if you've never played with it before. I highly recommend just typing the URL and -w, and it will prompt you through most of the rest of the way, and it will get you up and running. So if you've never tried it before, try it out. There's also this one I discovered while writing this talk. It's called PubSpider, and it's pretty cool. We'll have a look at it later. I've got a screenshot. But basically, it's like Google, but for website vulnerabilities. So if you, I'll show you the screenshot in a second. Okay, this is WordPress scan. It's enumerating some sites. It's found the Tim Thumb. It's found a vulnerability with the Tim Thumb X function. It's giving you a reference to the exploit, and then it goes through and enumerates the usernames and gives them to you. So that's really good if you can find a WordPress site, or if you're up against a WordPress site. This is PubSpider. So yeah, global web application vulnerability search engine. So here I just typed in A, clicked on title, and hit search, and I got a couple of thousand results, and it literally gives you each URL and with an indication of what it's vulnerable to. So it searched for about 7 different vulnerability types. So the first one is some educational facility in China, and it's got a blind SQL injection. The second one's got an XSS, and the third one's got 20 blind SQL injection. 20 blind SQL injections there. So yeah, you could go to town if you really wanted to.
Is it against companies, technologies?
So it scans companies websites for stuff, like broken stuff. So there's blind SQL, regular SQL, XSS, directory traversal. I can't remember what AMSI is, and XPath is, I think it's the XML XPath injection. So yeah, so it will search for those vulnerabilities on the website, find them for you, index them for you. So if you're up against a particular website, you may as well try your luck. Type it in here, see if you get a hit. Because if you have, then you can go straight home. You don't need to do any real work. Good. Okay, third phase is exploitation. So we've got a few different types there. So enumeration, brute forcing, ClickJacking, Borked crypto, code injection, CSRF, and attacking the EU. So we'll start off with the first one. So user enumeration is going, taking the authentication part. So what we're trying to do is work out the names or the email addresses of all the users on the site. And that will be useful for either social engineering or for brute forcing the password or for other things. So there's a few ways of doing it, but basically in ArcPX's case it was quite easy. If you just type in some random user, or I've given them the name no such user, probably does exist, but he's not registered on ArcPX, so ArcPX reports the message can't find the user null. If I did have a valid a valid user on the account, and I attempt to log in, I get a different message. In this case, I get the message that the user has not verified their email. I would get a different message if I had entered the wrong password and had a valid account. The point is that these messages can be scripted, and so you can say, download like let's say a password dump from any password dump that you find on Pastebin that's got username passwords already cracked for you. You can throw that list of emails in to your script, find the ones that actually exist on the website because they give you a different message to can't find user X, and then a lot of the time the password that they've used on that other site works on this site, so you can get in as them. So you win, which is great.
Isn't it really testing other site or this application, or looking for users somewhere else?
True, but that's true. So that comes into the next one, which is brute forcing passwords. So if that fails, so you can't find a pastebin that's been greenlit, you move on to brute forcing the account. So the user as a whole is still not that great when it comes to picking passwords. They think that their little trick that they're using to do their password algorithm is really clever and unique. Unfortunately, it's not. So yeah, and password reuse is still widespread, and people are not imaginative about their passwords. And another interesting point is that it's a little bit counterintuitive, but having a password policy actually helps the attacker in some cases, because all you need to do is look at the minimum password that a user would have to enter, and a lot of the time that's exactly the one that they've entered. So I think I wrote something down on this. Just let me give me a second. Yeah, so interesting fact is that when LinkedIn got hacked, LinkedIn got hacked this year or last year, am I right? But the attacker just dumped the password hashes, and no one knew what the password hashes were linked to. They didn't know where it came from until people started cracking them. And it turns out that a fair proportion of people's password had the words LinkedIn in there. So people were this was their really, really clever trick, because they were using a different password every site. Unfortunately, it was the site's name, which made it rather easy to guess. So that was a great one. A lot of the time, the password policy requires a number and or a symbol. And it turns out that everyone seems to use exclamation mark or the number 1. It's just like what some people do. And they always use it at the end. So you can run for the door to change your password now if you want. There was a great talk on why enterprise password policies suck by some guy from Corlan, and he made me go change all my passwords. So yeah, if you're doing something like that, then please change your passwords. Okay, this is how you brute force a password. There's a utility called Hydra. It's fairly easy to use. The command line is a little bit intense. But essentially, I'm brute forcing the account Borked builder, which is what I registered on ArcPX. I've got a dictionary file, common passwords, an IP address. The hydra has a number of attack methods. The attack method I'm interested in for ArcPX is the HTTP post. So HTTP form post is the attack method, and then you need to give it the URL and how to insert usernames, passwords, and that's what this user hat business is all about. Anyway, once you get the command line right, which probably takes a few tries, you'll end up with it humming along. You can do several thousand per second on a good connection, and it found my password in 13 shots because I used your pass as my password. So, yay. Sure.
It might be worth pointing out that these dictionaries don't go from A to Z. They're organised in order of probability.
Yes, so a lot of the good dictionaries are front-loaded for the common passwords. So if you do end up doing it, you'll find that your crack rate will start off high and then gradually trail off. Yes.
How are you checking the success?
So that's what this little thing here is. So the S success is basically saying you've got a 200 response. Yeah. So if you got some other response, you can. So some websites will give you 200 response even for a password incorrect. But there are various ways of configuring hydra to say ignore the code, look for some other string in the result that says you failed. So yeah, that's configurable. There's one more. Yeah.
Is it bypass maximum attempts at all, or no?
Sorry, say again?
Will it bypass maximum attempts?
It depends how it's implemented. So I've seen some good implementations. They're generally implemented at the network level. So if they see too many connections coming in from a specific IP address, they'll either throttle you or ban you.
Like a WAF.
Like a WAF, yes. So it's the WAF level. And there's also I saw one really good one. It was the website set a cookie on the response with a counter of how many times you attempt to log in, and when that counter got to 10, they would boot you out. So it's pretty retarded because you just don't send the cookie back to the server and you just keep going until you win. So that was really dumb. Anyway. Okay, next one is ClickJacking. Who's heard of ClickJacking? 1, 2, 3, 4. Yes, group. So it was fairly new, I think. It was originally considered as more of a prank, sort of like vandalism rather than actual attack. It does require some user interaction, so whenever you see one of those flash games where you've got to click, you got to shoot the iPad or something like that, I start getting worried because that's exactly how the sort of attack works. And the only way to win is not to play. There is so if you're writing a website and you're worried about ClickJacking, there are two ways of going. There's a JavaScript snippet that you can insert that basically checks the origin, or you can set the X-frame options to either deny being iframed, so other sites can't iframe you, and there's a sub option which may be useful if you do need iframing. It's for same origin.
Yeah, just wanted to add, so that Helmet library I was talking about before for Node.js, that includes this, and you can have that as a one-liner, and it's recommended to do that to stop iframes.
Yep. So you're probably asking, why is iframing so bad? Well, glad you asked. Okay, so this is what a ClickJacking attack would actually look like. So, what's happened is someone's put a Twitter submission or Twitter form, and they put that at the front of the web page, but they made the opacity 0, so it basically looks like whatever it is you want it to look like on the back end. So this is the quote from, if you want to look it up, have a look at this website. What I actually did was put your Twitter homepage on top of the button. So this is the button here, it says don't click me, but underneath it there's the button that says submit. And what that will mean is when the user thinks they're clicking don't click me, they're actually clicking the invisible button that's submitting this. And I've seen some pretty bad results, like people clicking on, clicking like a porn, and it comes up on their Facebook feed as liking porn. That's great. Yeah, happened to me. So yeah, that's great. Onto the crypto. So there's two sides. So for RPX, there was two sides to the crypto. There was the initial connection, the SSL connection that you make from the client, from the browser to the server, and then there's the crypto that happens within the browser itself, the JavaScript side. So when the user enters www.rpx.heroku.com, the initial request was in the clear, and the response back from Heroku was, oh no, 301, I've moved over to HTTPS. And that's great, but the problem is if the attacker's on the network, they can intercept the request, they can intercept the response, and instead of saying that 301, which is the resource is moved back to the client, they can basically say, yep, that worked, and send you the HTTPS stripped response. So at that point, the attacker would have to be on the net, on the same subnet as you, well, mostly, to be able to pull this off. But basically, they can insert themselves as a man in the middle and intercept all your traffic because your traffic is going in clear to the attacker. So the way to fix that is HSTS. We'll cover that in a second. The other attack is on the JS crypto. JS cryptos, if you Google it, you'll often find reports that it's really bad and it can't work and so on. This guy, Matasano, we wrote an article on it, which was really quite an insightful article, but I think he's missed a use case, which is the use case that RPX has picked up. I tried and I could not break the JavaScript crypto, that's probably not saying that much. All I can say is that I think that attacks will get better. The attacks always get better, they never get worse. There may be a JavaScript crypto break going forward, perhaps a timely attack or related. I don't know, but I couldn't find anything wrong with this approach. So a quote from that Matasano scientist: "What's so hard about deploying JS over SSL?" And his point was that you can't just send the single JavaScript file, the crypto bits, over HTTPS. If any resource of that site goes over the wire in the clear and is interceptable and modifiable by the attacker can insert malicious JavaScript code to basically neuter the JavaScript crypto or do whatever they want. They could insert their keylogger. At that point, it's game over for the client-server communication. So the idea is that we send everything over HTTPS, so we verify that no resources go over the wire unencrypted. And that initial request that you make unencrypted, the way to get around that is to use this extension called strict transport security. The way it works is the first time you ever visited that website, the response to the HTTP GET includes a header that says, hey buddy, whenever you try to access this website ever again, it's got to be over HTTPS. So none of this unencrypted business, and it sets a timeout. So that limits the attacker's opportunity to the very first time that website's visited, and that is a definite improvement on matters. There are a couple of issues. So again, if the attacker can get the user to visit the website for the first time and intercept, then they can win. There's also a problem on it's Chrome, where whenever you clear your cookies, the HSTS database gets reset, which is problematic. So if you can socially engineer a user into resetting their cookies and then get the first connection attempt intercepted, then you can win as well. So I've got 3 ways of your capabilities. So at least they only get access to the website. They don't get access to this whole thing unless they use a local privilege exploitation. Anyway, that's bad. Turns out CSRF is really easy, as I think we've noticed already. If you can get the uber secret password, then you can usually win against CSRF. And the other thing to note is the CRS value equals token has to be present for every input field. So if they forget to do it for one, then you can do a CSRF as well. Yay.
Isn't it token?
Sorry?
Isn't it token?
Yeah.
Yes. Yeah, so if it gets to it for a form, then you can CSRF it. Okay, so MongoDB, we've already talked about it. Versions prior to 2.4 and a few injection vectors. It's still mostly insecure by default, and you just need to have a look at the manual. Basically, by default, Mongo will bind on all interfaces. So, why is that bad? Why would it be bad binding on every interface? Yeah, private and public. And so what would you do to fix that? Not put it on public? No, but what are other things that you might do instead of just binding to the one? Yeah, so rather than doing that, what I've seen a lot of people do is firewall it off, and that says that they think that's great. The problem is that occasionally, especially in VMs, if the MAC address changes, the interface name will change. So we go from ETH0 to ETH1. So now your firewall rules don't apply, and everyone seems to forget IPv6, so you can get in that way as well. MongoDB, this is straight out of the manual, I'm not tweaking this. MongoDB does not enable authorization by default, so it's basically open to the world. Default distribution does not contain support for SSL, and the status interface is read-only by default. No authentication. And another interesting point was the status is always 1,000 higher than the daemon that's running. So if the status happens to be public, minus 1,000, and even if there's a firewall in the way, that's the port that you need to be looking at for attacking it with things like CSRF. So attacks within the perimeter. 2.2 had a hashing security. It's not really interesting. Yeah, because of all the insecurity, or because it's not secure by default, Metasploit have come out with a nice module that basically tries to find these open ports. So if you combine this with the Shodan search results, you probably have a lot of fun, depending on your definition of fun. There's 8 security recommendations by this Spider guys. I will go through them all because we're out of time, but basically do that and you're in a much better shape. If you do end up doing this, and for whatever reason you don't want to get caught, use Tor, use a VPN, and I highly recommend Unix. I use Unix, it's great. It stops. So even Tor has problems when you're, if you don't know what you're doing. Or worst case scenario, just sit at McDonald's with the Big Mac changer.
All right. So there's a Node security project. If you want to know specific vulnerabilities or adversary announcements, or even resources, a lot of the articles we talked about today are all linked there. This talk will probably link there as well in the near future. So yeah, keep an eye on this website. It's quite new, and they're trying to update it quite frequently with new issues all the time. And also, if you want to do more practical work with Node.js, there's a Node.js Node Goat project. It's still pretty new, but they actually give you some tutorials that work you through the top 10 OWASP vulnerabilities specific to Node. So have a look at that.